It's my privilege to welcome you back. It's Peter here from AJS, and welcome to another session of an online demo. We're coming to you from workshops all around Australia, and this week we're back in Chris Sherwin's workshop, and we're doing part 2 of creating hollow rings. Good morning to you, Chris.
Good morning, Peter, and good morning, everybody. Welcome to part 2 of making hollow rings.
I'm sure everyone's keen to continue the adventure. Chris, would you like to just recap on what we did last week before we set off into this week's journey?
Absolutely. Thanks, Peter. Yeah, so last week we covered this particular style of hollow ring, which is using the doming block to form a curved surface on a ring, taking it from a flat sheet, bending up the sheet into a band, and then using the doming blocks to squeeze that piece of metal down into the block so it creates curvature on both sides of the sheet. So we're going to I'll just quickly recap on that. There are obviously 2 bands. There's the sleeve and the outer curve band. The ultimate goal is to produce a ring. This one's got a little bit of binding wire on it, and it has a sleeve and a curved upper surface, and it's hollow inside. So I'll show you how we're going to today bring the 2 parts together and solder them together. So there are 3 rings. I've done a bit more homework, as I said. I've showed the samples last week. Again to recap, you know, this idea of this is you can use things like titanium. You can see the color in that ring is from the blue titanium. You can make rings in mokume gane, patterned rings, anything that you don't need to put through the fire you can make, as well as the silver and gold rings, which you can put through the fire. Now, I did show this ring last week. This is the one I'm going to solder. This is quite a sophisticated ring. It has a sleeve, a flat 1mm sleeve band that goes through, and this is actually 4 washer shapes turned up into 2 bands which have been joined together. And I've soldered 4 22 karat gold settings onto this. There are 4 stones to go into this ring. So you've got a baguette setting there, and on this side you've got 3 different 22 karat gold settings. They're already pre-formed, did all that work in the last week. And today I'm going to be fitting that sleeve in and showing you how to do that correctly and binding that in and soldering it in. So we get to sort of the caution part of the hollow rings, just so people are aware that there are safety issues. When you make a ring that's hollow, that you're going to solder closed, you have to think very carefully about sealing that ring up when you're soldering. When you form a sphere or a hollow section and you fully enclose the ring when you're soldering, there are dangers involved, because if you do not have an air vent in the ring or in the sphere, and you allow the sphere or the ring to cool down and you suddenly change your mind and you go back into resolder again, the atmosphere inside that solid surface will expand very rapidly, and you'll basically create a hand grenade, and that piece can explode on you, which could be life-threatening. So it's really important when you make anything that's hollow and you have enough experience to seal it closed, that you make sure that you allow for the expansion and contraction of the volume inside. And I, as a precautionary measure, tend to have an air vent in everything that I make that's hollow. There are other issues with hollow rings as well. If you seal them closed fully, they're fully enclosed using soldering, you've left the flux inside the ring. And a lot of people don't realise that that flux will eventually eat its way out of the ring. So I like to make the ring with some type of setting or an air vent, a little drill hole somewhere that's inconspicuous, which allows you to go back in and solder again, resize, repair with safety.
Great words of advice, Chris. Great words.
Yeah,
thank
so it has happened to me before. I tried to solder a 10mm sphere earring, and it actually had an air vent in it, but the flux covered the air vent while I was soldering, and I was moving my flame around, and I obviously cooled that sphere off, and I came back in again, and that gold sphere took off like a rocket, because once the borax came away from the air vent, it shot off, hit the side of a window which was in front of me, landed back here in my collarbone, and went down through my shirt. And it was lucky that I jumped up and allowed it to go down through the shirt. It would have burnt me alive, basically. So it is important that you heed the warnings that hollow things can be dangerous. Okay, enough is said about the danger. Everything's dangerous in this profession, but hollow objects, you have to be quite cautious. So I've also done a bit of homework on, this is the band we made last week. So started out as a flat strap. You can see the curvature there now that it's been domed in the doming block. And this will have this sleeve fitted to it today. So I'm going to curve up that sleeve. That will fit inside. And on the top of that, I've actually soldered a 18 and 22 karat gold setting for a lovely tourmaline, a lovely green tourmaline. I've got a cabochon tourmaline will go into that setting eventually. It'll go on the top there. Doesn't want to sit there at the moment, but it will go into that setting. Quite a nice big stone. The advantage is I've now got a hole through that setting, so this will be a hollow ring with an air vent. There'll be no problem at all about it exploding on me.
Ripper.
Which is good. So that's the ring I'm going to start with on this morning. This is the one we made last week, but I've just added the setting to it. And by the way, I'm going to post this to my Instagram feed and just show you some of some sequence shots, just so people can see how the setting was made. And that's at Chris Sherwin Design. So we'll start with the sleeve. I've prepared the sleeve. It's in excess of 65mm. I'm going to leave it a little bit long. It's 66mm long. I've drawn a little black line there. A little bit hard to see. There it is. I'm probably going to be cutting it off about 3 or 4 mils shorter. And I also have 4 little dots on there. There they are. That's where I'm going to be hallmarking this, because I'm going to mark the ring with my purity marks before it gets soldered in, because it's a very wide shank and I won't be able to get in with my punches to do that afterwards. So this is one of those rings that you can mark before you bend it up into a ring shape. Most rings you bend up and then you mark them, but this particular one's of quite a wide strip. It's almost 12mm wide. So I'm gonna mark that now. So I've got four marks to put in there: my maker's mark, the metal purity mark for sterling silver, my guild mark, and also the date mark for this year W. So I'm going to do that right now on my block. A little bit with the metal hammer there. And I'm going to use a very rough emery to take a little bit of the height off the bruising. If I push the bruising back into the metal purity marks, then the marks will I'm basically pushing the metal back in and obscuring the marks. So I just want to take a little bit of that excess metal off the back, and then I'll tap it again Then we'll bend this up using the hand ring bending pliers. Now it's important that your marks are not at the back of the shank. I noticed that some people mark their rings directly below the setting. So when you look into the ring, the marks are right across the bottom. You should never ever do that, because if you ever go to resize a ring, you want to resize away from the gemstones, and there's nothing worse than a maker's mark right at the bottom of the ring. So if you think of a ring like that, this is 12 o'clock, and obviously you've got 3 o'clock, 9 o'clock, and 6 o'clock. So at the bottom of the ring, if you've got your maker's marks right at the bottom of that ring, it's where you're going to want to cut it through. So always have them off to the side. So that's a lot tidier at the back. Another quick tap. It's quite a thin sleeve. It's not a millimetre, it's only 0.8 of a mil in thickness. So most of those bruises are out of the back there. See the shine, it's a lot flatter. There are my maker's marks from the front. So now I'm going to bend it up using the ring benders. And I think I said last week, if you buy anything from AJS, this is the tool you want to buy. They are absolutely fantastic. I'm now going to just set that roughly. And I want my maker's marks on the inside of the shank, so I have to make sure that they're on the inside. And I'm now just going to get some curvature. I think I want this ring to be about size O to finish. So I always bend one end and then go to the other end and start the curvature on the other end, because you do want your joins to be on a curve. So I'm sort of creating a U shape to start with. I'm now going to use my trusty bench bender just to get a bit more curvature at the very end. You can see I've got a really lovely curve there on that end. This end's a little bit flat, so I want to get a nice curve on that end. That's better. Two lovely curves. And now I can go back in and bring the ring together by curving the center of the band. Just gently bring it around. Just reset a little bit. It's got a nice little grub screw on the side, and you can reset the amount of curvature you get in any one round of bending. Close. We're now a circle. There's my join there. A little bit of a gap, but it's going well. And I want to just get that little clicking pressure. I don't know if you can hear that or not. Just get the metal to bypass underneath the shank by a couple of mils so you can pop it back out again. When you solder it, you want a little bit of tension on the band. And that's quite close now. But what I need to do is check my size. So I'm way too big. As I suspected, I've got about 4 mil to cut out. I want this around about 0.5 P, and I'm around about S.5. So I'm going to cut out now that additional metal. About 4 mil. Just going to use my square here. It's quite a wide cut. So that's nice and straight.
Are you using experience as your measuring tool, the 4 mil?
So you allow roughly 1 millimetre per size. So if I know I'm 4 sizes too big, then roughly on a 1 mil shank, I would take out 4 millimetres. Yeah, so it's just kind of fairly common knowledge that there's roughly 1 millimetre per size. But yes, it's experience, because I always work on the basis that size M is 56 millimetres in length, but then you have to allow for your metal thickness of band. So when you do your calculations, you have to find the diameter,
yep,
and then multiply by pi, and then add the metal thickness to get to size. So
just for our viewers, Chris, AJS have just created a little digital tool that'll tell them that. So you input the size of ring that you'd like, the band thickness, and it'll tell you the length of metal you need to start with. So
that's fantastic. Yeah, so that's a very handy thing. I also noticed on AJS you've got a tool for calculating carats. Was it carat weight? How to calculate for alloying, which I'm going to have a look at later.
Okay.
So
there's something new and exciting coming out, Chris.
Yeah, it's good. It's quite a resource at AJS website now, which is good. There it is. That's off. Quickly rebend that. And again, that's the other advantage. If you're keeping that ring round rather than this, with the flat spot, it's nice and round. You can keep checking on your mandrel, because you're getting a pretty clear picture of how close you are to being to size. So that's now down to about P.5 Q. It's quite close. Now I'm going to always go back. If you've got 2 pieces, go back to the ring, see what you're doing. Yep, I can definitely afford to take another couple of mils out of that, and then that should fit. So I'm going to the other side of my line this time. Take another 2 mil. I've got to be fairly accurate with this one, because it's a wide band and it's thin metal, and it would be quite hard to tap up and resize. But as we said last week, one of the challenges of making these hollow rings is that you have multiple measurements you have to keep in mind. And remember, we talked about the fact that when you do make up your initial band and you are making your hollow ring, you have to allow for 7 to 10 sizes in reduction. And that does make it pretty tricky. And unfortunately, there's no real formula for that. So that's not too bad. I'm down to, I guess, about size P, a little bit oversized. And I'm just seeing how close that is to going in. It probably needs another millimetre out. I'm trying to make this for a customer. So I'm hoping to get a sale out of this. So I want to make it to a real size. I think she's about 0.5 P, so I'm quite close. So I'll continue on with that. We might get back to that in a little while. I want to show you some soldering. So that will, I can push it in now if you like, but that will squeeze into that shank. Difficulty, that will go in there. I'll have to solder it together first, of course, run that join through, a little bit of cleanup on both rings and get them to fit perfectly, and then they'll be bound up, and then I can solder both sides. So we'll come back to that one in a second. I just want to show you how to solder this other sleeve in that I prepared. So this is this complex ring with the 4 settings, which I've got to fit this band into. I have cleaned up the outer edge of that band with 600 emery. because it's important that there's not a flared edge on that, and it's also important for soldering that you have a good sterling silver to sterling silver contact. You may or may not realise as you make jewellery that, especially working in silver, it's probably the most challenging of the metals to work with. You cannot actually join properly silver to silver if it's not clean back to sterling. This has been through the pickle, this piece is actually quite white. If I try to join something to that surface, it will be a brittle join. So it's always important that when you solder, you clean back your surfaces to be soldered, not the whole piece, just the surfaces to be soldered so that they are a fresh, flat, clean sterling silver finish. Cleanliness in soldering is very important. So that sleeve fits in beautifully in there. I've also marked the sleeve with a black texture so that my sleeve sits over the join of the other ring. So all my joins are lining up. You don't want joins all around the ring. And also my hallmarks around the side here internally. So I'm not going to be cutting through those. They're away from the join. So I'm going to get that little line, black line lined up. The sleeve's sitting in nicely. I've got my binding wire, which is, I think it's around about a 16 gauge. I've doubled up. I'm going to feed that through the top of the ring or through the inside, because I've got a small edge to solder to at the top and then quite a large edge to cut off at the bottom. So I'm going to pop that binding wire on.
Chris, did you get to explain why you put the 4 hallmark stamps down one side rather than in the centre?
Yeah, because as I said, if you are making a ring and you wish to have longevity and to be able to be serviced and to be resized, it's pointless having hallmarks at the bottom, because this is where people will cut through. This is where the joins are in rings. It's always good to have them off to the side. And I always talk about the 3 o'clock and the 9 o'clock position in a ring. Mm-hmm. And if they're in that position, you've allowed 3 or 4 mils, 5 mils at the bottom of that ring to be cut through to be resized. So it's very important.
Oh, perfect. And just, well, I've got you just a comment from Robert, who's appreciating the way you curved that metal to create your ring, because he was taught to create a D shape, but he's preferring your method a lot more.
Oh, thank you. Yeah, you can. So the actual, this is the curve of on the band.
Or yeah, how to create the curve. Yeah.
How to create that curve with the.
Oh, going from a flat piece of metal to your curving.
Yeah.
Yeah.
Okay. Yeah. No, that's right. A lot of people do a D shape, and it's actually not. It's not good at all. A lot of people are taught that. It's much better to join on the curve. Takes a little bit more time, a little bit more skill. But you reduce all these issues that you can have all sorts of tensioning issues afterwards. It's the same with your settings as well. If you join settings and D shapes, you're really not helping yourself in the longer term. Just going to tighten that a little bit. I'm going to put in 3 lots of binding wire here. A bit like a good old Mercedes symbol, just to hold that sleeve in position. So it's doubled up binding wire. It's got this sort of, again, that's experience, but it's got the sort of tension that I'm after. That's the second one, and I'll put a third one in, and then I'll just readjust the sleeve to sit in the correct position. Put that one through this side. Remember, when you twist your binding wire, always pull on it. So you straighten and tension it correctly. I'll cut that excess off. I always leave about 4 mils sticking out if I can. That one's a little bit loose. So I'm now going to check the alignment. And there we have it. The ring is tensioned. The sleeve is on. I've got the sleeve protruding. It has a taper to it, this ring, so it's quite a complex ring to make. But after I've soldered this together, I'll be cutting off that that taper on the band. That's okay. All right, so we're ready for some soldering. Use some medium solder. Make some smaller pieces, but I've got some larger ones as well. It's quite a large join. I use a nice little tray to cut my solder into. Just cut off multiple pieces, roughly the size you think you're going to need. It's a little bit big. My trusty solder snips, which are great. I just spread this solder on my soldering area. Hopefully you can see that.
Yep.
They're little 2mm chunks of sheet solder in medium. And I've also got some quite heavy pale-ons. I do a lot of silversmithing, larger work, so I do work with bigger pieces. So these will be handy just to quickly fill in. We will need a lot of solder here. There are two sides of the ring to solder, but I'm trying to do this in one basic operation. We'll start with that. Get the torch fired up. Now again, I'm using my boric borax mix, 2 parts boric, 1 part borax. You can get this from AJS in nice little drums. Really important to keep your silver clean, incredibly important. A lot of people just don't do this. I don't know why. This is methylated spirit, so I have to be quite careful. I'm trying to reduce the amount of fire scale that this ring has in it after I've soldered. And because I've soldered all these 22 karat gold settings on, I actually don't want the solder on those joins to run. So the boric mix, which is great for gold soldering, is a little bit high temperature for silver. So it tends to, it does clean, but it tends to hold back your solder on your previous joins. I'm just going to fire that up. You may not see that's on fire, but I assure you that is on fire.
Yeah, we got it. It's big.
A little bit of a green flame. It's still going.
Cheers.
It's so that's flambeing, and that will coat the surface. I don't know if you can see the surface. It gets quite cloudy and powdery. I'm going to do that a second time. Let's put the fire out over here. I once almost set the workshop alight doing this, so you have to be very careful if you use metho. You could do this with water, but you'll find it won't stick. The beauty of the metho is it's very sticky, and it allows the flambe to stick on. Again, I think I've sort of honed my soldering techniques over 30 odd years, so that's on fire again. Oops, fire's dropping down here somewhere. And that's given me a really nice white powdery coating, protecting all of my, in fact, you can see all of those settings have sort of disappeared under the powder of the borax. Mm-hmm. So that's ready to go now. So now I'll apply my tenacity to just the area that I wish to solder, because the tenacity is specifically designed to allow solder to run at the temperature that solder runs at. And it's important to keep that very, very clean. And the borax mix will tend not to run. It'll start to glass a little bit, but because it's a higher temperature, it'll tend not to run. So this is going to take a little while. We'll see how we go with this. I'm going to bead up the solder first with a smaller flame. If you do bead your solder, don't overheat it. It's easier to cook your solder. Just a gentle flame. Some people like to just put the pail on straight on. I don't like doing that because the pail on, if the object you're heating gets hot very quickly, the pail on will burn as a little square pail on, and you'll have little square burn marks everywhere, which I find really annoying, because the pail on will bead up before it runs anyway. The advantage of having the bead is I can place it much more precisely. So if you do a lot of very fine soldering, as I do, by making a bead, the bead gets very close to the soldering joint. With the pail on, you're in the general area of the soldering, and you can't control what happens to it as it beads up. It can bead up and then flow away from your joint. But with a ball, you can place it right on the joint. So that's my practical tip to you, that you bead your solder. So I've got my tenacity's got a little bit dry. Just add a tiny bit of water. You don't want to add too much water to tenacity. Just nice and pasty. Gently heat the ring. Remember I said this last week, don't apply your flux until the ring is warm. And just fizz it into your join at that 100, 150 degree mark. I want to bring the ring up to temperature slowly because I don't want to anneal the binding wire too early. And I'm just drawing that flux into that join nicely. I'll turn it over and do the same on the other side. So just trying to maintain that 100, 150 degrees, just enough for the water to fizz while you're applying your flux. And I can actually see it drawing down. Can you hear that fizzing away, Peter?
We can, yeah. It's very impressive, Chris.
So just controlled, clean. I've got the flux where I need it. Looks like it looks like it's got a disease, this ring. It's all fluffy and powdery, but it's exactly what I want.
So Robert referred to before that you were sort of ghosting it. Is that?
Yeah, that's it. I like that. I'm ghosting it. Yeah. Nice powdery mixture. Okay, so I'm going to need quite a big flame for this. It's a big ring. I'm sitting up on a little steel mesh, little bits of fire brick, and I'm very slowly going to bring that up to temperature because I want to make sure that the binding wire does not suddenly go red and anneal, otherwise the sleeve could slip. I don't want that to happen. It will eventually anneal, and it gives me a chance to keep an eye on the flux, and my flux is now getting sticky. And now I back my flame off a little bit. So I'm going to now start applying my little beads of solder. Oops. So my technique is I use the titanium tweezers, pick up the bead with the heat. There's a tiny bit of flux on the end of the solder tweezers, and that holds the bead to the tweezers. And when I apply heat to the ring, as long as the ring is hotter than the tweezers, I know you can't see this on the other side, but the bead of solder will transfer across onto the ring. You can see the two little beads there?
Yep.
So as long as that ring stays at that temperature, that constant temperature of around about 350, 400 degrees, and glassy, all of those beads will sit exactly where I want them to be. I'll just transfer across, pick up a bead, heat the tweezers, release it. There's the bead on the tweezers. Reheat the ring, bring the bead across, and then release it. And all of those beads are sitting on the ring. So it's very hot. See those little beads there?
Mm.
Space them out, I guess about 5-6 mils each. So you have to maintain the heat on the ring. You have to maintain this glassy, very low glass effect. Otherwise the beads will fall off and you'll have to start again. I'm almost there now. One more bead, I think. Maybe a couple of small ones at the top here because I've got my setting at the top. So I'm going to do one side at a time. Okay, so all my beads are now in position. I've got beads all the way around that ring with the amount of solder which experience tells me should be enough to fill the gap. I just visually check that they're sitting in position, make sure that my sleeve's in the right spot, hasn't moved anywhere. It's coming through to the other side. Okay, here we go. So I'm going to want to tack one spot first. It's a very big flame. And there's a little bit of orange in the flame, slightly reducing. I want to bring the ring up to temperature slowly, and then I'll concentrate on one area and then work that join all the way around. You definitely have to work silver differently to golds because silver has very high conductivity. So you need to have a broader general flame rather than a hot pointy flame with silver. So most of the ring has to be very hot. I'm just nudging the solder a little bit with the tweezers. There it goes. Got a little bit of a gap here, so I'm going to have to fill a bit more.
Chris, got a question. What size torch tip are you using there?
Oh, good question. This is a number 6. So quite a big tip. Just going to cool off my tweezers in the water. Yeah, number 6, number 7 tip, good for a large job on the micro torch. Just heating the other side now. Here we go. Solder's just pulling down nicely. Down it goes. Down it goes. And that should be all the way around. Need a little bit more. It's taking me a bit more solder than I thought. That's why you always cut a bit more.
Be
You
prepared.
never have enough solder. A couple of more beads and then I'll stop and I'll show you what that looks like. And a lot of people get anxious when they see, all of the flux going green and red, and it all gets very dirty, and they race away and they plunge it into the pickle at some point. That you do not want to do. That's not a good move. Because once you pickle the ring, any unsoldered surface will then enrich with fine silver and you won't be able to solder it properly. That's looking great. Just turn that a bit more. What I'm doing is I'm running my tweezers through the glass at a temperature just lower than soldering, just to make sure there are no gaps. I'm going to put one more bead of solder in here. Make a bigger bead. It's worth just taking your time when you're soldering to make sure there are no gaps. As I said, if you run that titanium tweezers through the solder as it runs, that's fine. And then as the solder freezes, it goes hard, you can continue to run the tweezers through the gap to see whether you've got a black line or whether the solder's filled the gap. Okay, that ring is obviously very, very hot. Make sure there's no glass there. And that's now soldered on one side only. You can see probably the coloration of the flux there. It's quite dirty, but I haven't done this side yet. So I've still got my binding wire on there. So what I'm going to do is I'm just going to let that cool for a second. Just check it visually. Just cool that off into water. Never, ever, ever put silver hot into the pickle. Never do that. You're just inviting the pickle to enter the surface of the silver, and you'll ruin the material. So at this point, I'm going to cut the binding wire off because there's no chance of this sleeve moving. And I'm going to continue soldering. We've got enough time. I'd like to sort of perhaps finish this off a bit more. But my word of advice is do not put this into the pickle. You might think, oh, it's a bit dirty, I can't see what's going on here. You really do want to get all of your soldering operation done before you go into the pickle, because this demonstration is not only about making hollow rings, but it's about soldering them and good soldering practice. So I'm just cutting off my binding wire. A lot of people just don't seem to learn about silver, that it should not go into the pickle until the soldering operation is completely over. And lovely, I managed to get the 3 bits of binding wire off. There's no connection there. So that's soldered on this side. You might be able to see where the solder has gone around. It's quite brown on the join there. A little bit hard to see, but that's fully soldered. And the other side is the side I still need to solder. Just visually check your join, make sure you've got enough solder on the first one. I'm really happy with that. And now I'm going to go straight back and do the other side. So if you've got any questions about soldering, throw them to me now.
Well, you've got a big fan in Robert. Robert was with us last week and is enjoying this week's session as well. And
good on you, Robert.
He just thank you for busting another myth there. So
yeah, it's obviously it's taken me a lifetime to learn these things, but yeah, there are a lot of myths about silver soldering, and it's really unfortunate. But yeah, pickling is probably the very, very last thing you want to do. If you can't see the job because there's flux everywhere, then you just use boiling water and get the flux off using boiling water. The minute you go in there into the pickle, you're committing yourself to probably bad soldering techniques. We're not working in gold here. This is silver soldering, and it's completely different from gold soldering. But I must admit, it's taken me a lifetime to learn this. And it does take you a long time to understand how fire scale affects solder, and the actual process of soldering, what sort of temperatures that you are operating at, and how to work with your flux. I guess it comes pretty automatically to people who've been doing it a long time, but it's not so straightforward for someone learning, that's for sure. Mm. Okay, my big chunky bits of solder here. How are we going for time, Peter?
Always got time for you, Chris. So.
Got about quarter of an hour left. I think we should be able to get this done in time, and a bit of a clean up. And as I said, I'll post any pictures of the final clean up on my Instagram site, and you can go through and see that. Just quickly bead these up. 3, 4, 5, 6, 7, 8, 9. There's still plenty of flux on there, but I could flambe it one more time just to protect it. I'm sure as a student, I got used to putting everything into the pickle straight away so I could see what I was doing and didn't realise the harm I was doing. So you've got to remember this hollow ring now has the air vents because I've got holes through where the settings are. So there's should be no issue of the damn thing exploding on me. I hope not. And just reapplying flux to that second join. It's got very dark, very red, the flux, because it's absorbing the copper oxide. Takes a while to bring it up to heat. And you'll see that boracic, the tenacity will change colour and become glassy. So the good thing is about flux is you'll start to read what they're telling you from their colour. Just run my tweezers through. I want that to be just sticky. And now I can apply my beads of solder. On they go. Just drop that one. Damn. That one. That one. That one. Come around to your side. One there. One there. Some days you have good days. You can be really quick at this, and some days are slow. This is not too bad. Almost all the way around. One more big one. And we've got all the way around. And when I get my beads on, I then readjust them. So I just reheat, make sure they're all pushed up to the join. Push that one up a little bit. Don't get your tweezers too hot, it'll stick to your tweezers. They're all looking good. Here we go. Got lots of birds where you are, Peter.
Yeah, including the occasional crow, hey?
Yeah, I got the crow happening. We had a few black cockatoos around here recently. It's been quite nice.
If you got time to answer a question or two?
Absolutely.
Okay. Could you please give the borax recipe again, Chris?
So it's 2 parts boric and 1 part borax. So it's good to get maybe 2 spoons of boric acid, teaspoons, and 1 teaspoon of borax. And you buy the powdered form from AJS. And mix that with a bit of methylated spirits. Just keep it wet and you'll be fine. There goes my solder.
Okay, that was from Fliss, so thanks for that, Fliss.
2 parts boric, 1 part borax. It's a good flambe mix.
And Chris, another one if you can concentrate.
Yep, I'm good.
Well done. What's the easiest way to remove the binding wire if it happens to stick to the solder?
Good question. Well, I try to roll it out with the pliers. So just work with the pliers and pull it back on itself, roll it out. And then if you've got way too much silver solder with your binding wire, you're just going to have to file it out. There's no great trick there, but you do have to get it off, that's for sure, because you can't put it into the pickle with binding wire on it.
Okay, thanks for that question, Tracy. I'm sure that's helped other people as well.
Okay, I think we're done here. Very hard to see what's going on. There's a lot of flux, but I think we are done. So I'm going to let that cool off for a little bit. I don't want to shock it. Very glassy, very dirty now, but that's you can see all the different colors there of the green on the inside and the brown on the outside. That's just the tenacity doing its job. Very glassy. But as I say, with experience, you get to work with the glass rather than against it. It's a very, very bad habit to keep putting things in the pickle. I know I keep saying it. Pickle makes everything look easier, white and pristine and lovely, but it actually works against you. So that's down to around about 400 degrees now. So I'm going to quench that off. Into my trusty Degussa pickle. Yeah, so binding wire, it can be a bit of a nuisance. You try to roll it back on itself. So I tend to get the pliers and grab the bit that's left over that's not stuck down, and then actually roll the pliers back, a bit like, you know, opening those old-fashioned sardine cans.
Yep.
And that will tend to pull the wire out of the solder. But if it's well and truly covered in solder, then you'll obviously have to get in there with some needle files and get most of it off before it goes into the pickle, I'm afraid.
And just a comment from Robert about you mentioned the birds. He said, lucky his microphone's not turned on because he's got rainbow lorikeets.
Okay.
And they can make some sort of din, can't they?
They can. Good on you, Robert. It's nice to be where you can hear birds, isn't it?
Well, it is, yeah.
So almost done there. I'm just going to go back to my, any more questions, just throw them at me.
Will do.
I'm just going to go back to the sleeve for a little while. So I'll try to post this on my Instagram feed so you have a few still shots of where we've got to up to this point. Yeah, I'm going to take one more chop out of this. And we'll take our piece out of the pickle. So I'm hoping in the next lot of demonstrations to maybe cover some gem settings, but using some of these techniques again, using the doming blocks and some setting plates to make settings up. So if you want to give Peter some feedback about what you'd like to see, I'm happy to take that on board.
Yeah, please pop those in the comments if you'd like Chris to do something in particular next time.
Yeah, there's a lot of these particular techniques you can take on to other areas of making jewelry, and it just consolidates learning, because learning is all about trial and error and learning from your mistakes. And I guess because I've tempted people by using a few gemstones in these pieces, they'll think, oh, how did he do that? So we'll try to keep people enthused.
So Robert's asked, is it easier to solder gold than silver?
It's definitely easier to solder gold than silver, absolutely. Especially, 18 karat gold, because you don't have the fire scale issues. You don't have to use as much flux, and you can use a very hot flame when you're working, because you can pinpoint, you can bit of general heat on the object, and then you can pinpoint exactly where you want the solder to flow. For instance, putting a setting on top of a ring or putting a core onto a setting. With silver, you can't just simply put a core onto a silver ring without heating most of the ring to the same melting point. You've got this huge transfer of heat in silver, very, very good conductor of heat, whereas gold is a poorer conductor of heat. So you've got all sorts of issues of cleanliness and how the metal conducts heat. And that's the issue with platinum. Again, it's a very poor conductor. It's very easy to solder. Very hot points at a very small area. You just can't do that with silver. If you try to put a very small object on a very large silver surface, you have to heat the whole surface. You cannot come in with a hot flame and solve that little point.
Right. Yeah.
The heat just races away to the rest of the object until the rest of the object gets hot. So it's quite a challenge.
Indeed. Another question for you on solder is, can you use silver solder on gold?
Absolutely. So it depends on obviously what you're trying to do. Give that a second more. That's looking beautiful. My question would be, why would you use silver solder on gold? But for instance, when I soldered that gold setting onto this silver ring, I could have used 18 karat medium solder, but the risk is fairly great that I'm going to melt the shank. It's fairly high temperature, but I did actually solder that on with silver solder, that gold setting. So the answer is yes, you can silver solder anything really. You can silver solder stainless steel with silver solder. But yeah, normally you would stick with the solder that that you're using for the metal that you're using. But in this case, multicolored gold with silver, you have to then, experience will tell you which solder to use. And because I'd used a lot of medium silver solder here, I wanted to reduce risk and soldered that setting on with silver solder. But I was very careful about it, extremely careful, because the silver solder will burn into the gold and it will tend to leave a little trace of itself, which is not nice. And this ring is ready for cleanup, which we sort of ran out of time there, but it'd be nice to show you this. It's fairly clean. It's now nice and white with the gold settings on it. That sleeve is fully on there, but there's a lot of sleeve. You can see all this has to be cut off on this side. All of that has to be removed. And this small edge here has to be removed all the way around. So the edge is very fine at the top on the sleeve, and it's quite wide. As I turn it around at the back, all of that sleeve is cut off so that the ring has this lovely tapered shape to it and probably a nice comfort fit. So, and I'm just checking that visually with my beady glasses, and I've really judged that quite well, if I do say so. Just the amount of solder on there has left no gaps. You can see the little bits of solder rest on there, slightly excessive, and you tend to need to do that with silver. You tend to have a little bit of an excessive solder so that you can clean it off afterwards. But I'm really pleased with how that's come up, and I'll post that under my Instagram post so people can see what it looks like finished.
Oh, that'd be great, Chris.
So hollow rings, hope you try them. Get yourself some doming blocks and punches. You'll never regret that. Give it a go, work safely, and I wish you well. And look forward to seeing you soon.
Thank you so much for taking people on that journey, Chris. It's really not so much about the destination. It's all about the little tips and tricks that you pick up on the way. Because if you let yourself down in one area, you're going to let the whole job down, aren't you? So,
yep, there's a lot to learn, and that's what's kept me fresh. Not quite as fresh as a daisy, but it's what's kept me fresh. You know, learning, constantly learning, trying to pass that knowledge on to people. There's so much to understand, and you know, that empowerment makes you feel good inside when you know you're giving the customer a really good job because you felt comfortable making it. That's what it's all about. Yeah.
Well, we look forward to hearing how you go with the sale of that ring too.
Yeah, I'm sure. I've got a client in mind for that, and I'm sure she'll love it.
So what also impresses me is the way that you measure without a ruler, and you gauge heat temperatures without a thermometer.
Yeah, I guess I've been doing this such a long time. I do a lot of reading, so I've done a lot of research. So yeah, I guess I could talk for hours about it, but I'd bore you all. But you have to learn through experience, do lots of reading, and keep watching these demos, because I'm sure you'll keep learning more and more, and you'll have more questions, which is good.
Indeed. I'll just check the comments section. Thanks, Chris and Peter, for providing this teaching experience. That's from Robert. He's a big fan. So
thank you, Robert.
Thank you so much, Robert. And also we've got a comment from Michelle. Beautiful work. Thank you. There you go.
Thank you,
Can't
Michelle.
get a better compliment than that.
Yeah, no, it's lovely.
Yeah. Well, thank you once again, Chris. We look forward to having you back real soon. And we'll look forward to that occasion.
I look forward to it, and I'll keep challenging you. So keep practicing. And thank you, AJS. This series will be really good. Thank you. Thanks, Peter.
Thanks, Chris.